Hello guys, this is Siv and today we'll discuss about a singly linked list. So first we will discuss the what is the singly linked list with the help of this figure, and after that we will discuss the flow of the program, and after that we will run our program and we'll try to understand practically what is the linked list, how we can create the linked list, and what are the different operations which we can perform on the linked list. So let's start. So guys, as you can see here, node. So first we need to understand what is node. Okay guys, so as you can see in the figure, node is divided in two part, data and address. Okay guys, so data contains some information which a user want to put in the node, and address part contain the address of the next node. Okay guys, so as you can see here, these are the some different nodes which contain some data, 10, 20, 30 and 40. Okay, and these nodes are connected with this arrow one after another. Okay, so these arrows are nothing but pointer, because this node in green part, this green part contain the address reference of the next node which contain the data 20. That's why this arrow from 10 to 20 denoting means this arrow is denoting a direction from 10 to 20. Like this same logic is implemented for the further node also. So these nodes making a list by pointing this uh, we can say pointer by this arrow. Okay guys, so uh, these nodes making a list, and that's why these nodes are also means after making the list known as singly linked list. Why it is singly linked list? Single means one, link means pointer, because to connect from one node to another node we are using only one arrow, one pointer. That's why it is known as singly link and list, because in singly linked list nodes are arranged in a sequential order, as you can see, one after another. Okay guys, so after making a list in a sequential order, we can perform different operation in this singly linked list. Like if we want to print the data of the list of singly linked list, then we will get the order like this: 10, 20, 30 and 40. Okay, and if we want to reverse the order, then we can reverse the order also. So we will get the order means the data like this: 40, 30, 20 and 10. Okay, means 40 will be placed in the first position, 30 will be placed in the second position, 20 third and 10 in the fourth position. Okay guys, so like this we can reverse the order also. We can delete any node. Suppose that if 30 will be deleted, then 20 will means that the address which contain in the node which contain the data 20 will denote to the next node after the deletion of the 30, means it will denote to the 40. Okay guys, and one more thing, a node which is in the last, here you can see a node which contain the data 40, after that there is a no node, so address part will contain the nothing, null. Okay guys, so this will denote that our linked list is end here. Okay guys, and another operation is, suppose that we want to add a new node between any two nodes. Suppose that we want to add any node between 20 and 30, that we can also do that. And if we want to add any node in the beginning of the list before 10, we can also do that. Okay, if we want to search any data we want to check that any data present in the list or not. Suppose that we want to check 30 is present in the list or not, then we can also do that. So like that we can do different type of operations. Okay guys, so now let's move to the discussion of flow of the program. So as you can see here, this is our program. So first I commented linked list first, because this is our first program under the topic linked list, and here we will discuss the program singly linked list using C programming. Okay guys, and what is the singly linked list? All the nodes are arranged sequentially by linking with a pointer. Okay guys, so first here we wrote has include stdio.h, stdlib.h. This is the declaration of the method display which will display the linked list. This is our structure node which contain two data, info integer type and a pointer link struct node type. Okay, so this info is nothing but the data part, and this link is nothing but it will contain the address of the next node, which will be type of struct node type. Okay, as in the figure, this is info blue part, and this green part is the link part. Okay guys, so here this is the starting variable start, which is type struct node. Okay, so this is our first node. So as we will proceed further, you will get the better idea. So let's move further. So this is our method check empty list, to check the list is empty or not, means a singly linked list is empty or not. So I will explain this method also. First take some glance. Okay, so this is the another method check repeated data. We will check that data is already available in the list or not, which we are going to insert a data. Means suppose we are inserting a data, first we will check that that data is already available or not in the list. If it is available, then we will not insert that data in the list. Okay, so it is depend on the user preference. If you want to store duplicate data in the list, then you can, but in my program I am not storing duplicate data in my linked list. Okay guys, so this is the create list method and this is the add at beginning method, add after, delete to delete the node from the list, from the singly linked list, display method to display the data in the singly linked list. This is the count method to count the number of nodes, how many nodes are available in our linked list. This is the reverse method to reverse the linked list. This is the search method to search any data in the singly linked list, and this is our main method. Here execution of the program will start. So we'll start from here. Okay guys, so as you can see here, I have taken some integer variable choice nm position I. Okay, this is the struct node struct node pointer type of variable start, and this is null in the starting, so it is showing that linked list is empty. After that we will clear the terminal by this line of code, and here we will run our while loop for the infinite time. Okay, and here we will print some menu in the screen: create linked list, add at beginning, add after, delete, display, count, reverse, search and quit. So here we have given some number 1 2 3 4 5 6 7 8 9. So whatever choice user will enter, here we will ask enter your choice, and we will take the input from the user. So whatever choice will be entered by the user will pass to the switch statement here. Okay guys, so here first we will clear the terminal and will pass the choice entered by the user to the switch statement, and accordingly we'll call the cases, case 1 2 3 4 5 6 7 8 9. Total we have 9 cases, and if a user will enter other value other than 1 to 9, then it will send to the default case. Okay, so here wrong choice message will be printed in the screen. So in case first actually we will create the list. So first what will we will ask from the user how many nodes you want. He will enter number for the nodes. After that we will ask he is sure or not. If he will enter y for the sure, then we will do nothing. In the case of else, means he is not sure, he want to change number of nodes, then we will come out of the case statement by this continue statement. Okay, so if he will enter y, then we will proceed further. We will take a variable I will equal to, will assign 0 to that variable I, and will run the while loop till I will be less than n, what is the value entered by the user for the node here. This while loop will run, so we'll ask the value, enter the element. Okay, so he will enter the data to insert in the node. We'll call the method check repeated data, that whatever value user want to enter, it is already available or not in the linked list. It will check. If it is true, then we will ask again. We will write continue. This continue, what it will do, it will ask again the element, means again it will ask this method, means this statement enter the element. Okay guys, so user will again enter the value and it will again check. If it is false, means repeated data is not available in the linked list, then we will create the list. Okay, by calling this method create list, and will pass the data which is entered by the user here. And will increment the I, and again while loop will check this condition, and when this condition will fail, then we will come out of this case 1. Okay guys, so in case 2 we will add the data at the beginning of the linked list. So first we will ask from the user enter the element. He will enter the value. We will check data is already available or not in the list. If it is available, then we'll ask again this method, this message enter the element, and we'll ask again the value. If it is not available, then we will proceed further and we'll call this method and add the data at the beginning of the linked list. And after completion of this method, we will call this a break statement and will come out of the case 2. Okay guys, in case 3 we will add the data after the particular node. Okay, add after method will call here. So first we will check linked list is empty or not. If linked list is empty, then we'll call the continue statement and will come out of the case 3. When we will come out of the case 3, then again it will ask the menu, means menu will come, and again it will ask the enter the choice what he want, means this menu will come again. Okay, so continue means that. So we were in case 3. Here we will ask if a duplicate data is not available, if a linked list is not empty, then we'll ask the value to enter. User will enter the value, it will come here, and will ask the position, enter the position, after which this element is inserted. Okay, he will enter the position, will check the repeated data whether it is available or not. If data is repeated, then we will call this continue statement, and again will main menu will come here. If data is not available in the linked list, singly linked list, then we'll call this add after method, will pass the data and position in this method, and after completion of this method we'll call this break statement, and will come out of the case 3, and main menu will again display to the user. Okay guys, so here in case 4 we will delete the element from the linked list. So first we will check that linked list is empty or not. If linked list is empty, then we'll come out of the case 4 and main menu will print. And if linked list is not empty, then we will ask from the user, enter the element for the deletion, means what data he wants to delete. He will enter his data, will call this method delete, and will pass the data to this method. And after deletion we will call this break statement, and will come out of the case 4. In case 5 simply we will display the linked list, whatever linked list we have, and after that we will call this break statement, and will come out of this case 5, and main menu will print. In case 6 we will count the number of nodes in the linked list. So first we will check that linked list is empty or not. If it is empty, then we will come out of the case 5, and main menu will print. Main menu will display to the user by using this continue statement, and if linked list is not empty, then we'll call this count method to count the number of nodes, and after completion of this method we will call this break statement, and will come out of the case 6. Okay guys, case 7 we will call this method reverse to reverse the linked list. Okay, means right to left and left to right, vice versa. Means a element which is in the rightmost will come to the leftmost, and which element which is in the leftmost will come to the rightmost. After reverse we'll call break statement, and will come out of the case 7. In case 8 we will search the data entered by the user. So first we will check linked list is empty or not. If linked list is empty, then there is no meaning to search the element. If linked list is empty, then we'll call this continue statement, and will come out of the case 8, and main menu will be displayed to the user. If linked list is not empty, then we'll display this message, enter the element to be searched, means which data he wants to search, user wants to search. Will take the data from the user and call this method search, will enter the value entered by the user, will pass this value to the search method, and after searching break statement will come, and will come out of the case 8. Okay guys, and in case 9 we will come out of the program by calling this exit by passing the value 0. Okay, by this method exit, and if a user enter any other value 1 to 9, then he will come to the default, and message will print in the terminal wrong choice. So like this our main body is completed, and now we'll discuss one by one all the methods which were present in the case switch statement, Okay guys, so we will start from here. In the check empty list we will pass a variable which is type struct node pointer start, and if start is null, if it is equal to null, means that singly linked list is empty, will print the message to the terminal, linked list is empty, will return -1 in this case, otherwise will return 0. Okay, and check repeated data, will pass the data which we want to check. Will take the pointer type of variable struct node. Q will give the address of the start node, integer variable pos for the position, and will run the while loop till q is not equal to null. This while loop will run. As q will equal to null, we will come out of the while loop, and we'll check here if q info. Here q is nothing but node. Okay, node address. Okay, q info means a data part. As in the figure we saw, q info means 10, 20, 30, 40. Okay, so data, if data which we want to search is equal to this q info, then we'll print the message that data already available in a linked list at position. We will print position also. Okay, and we'll print the linked list by calling this display method, and we'll return 1. Else we will give the note, we will means a node will get the address of the next node. Here q link is nothing but this. Q link is this. Suppose that this node which contain the data 10, this is q, then q info is 10, q link is this node address. Okay, so when we are writing this statement, q equal q link means now q will get the address of the next node, means this q link is equal to q link. This is the q link. Now q will come here after this statement, q equal to q link. Getting my point or not? Q link is this, means this address, so q will get this address. Now q will shift here. Okay guys, so like this while loop will run. So as suppose that data is this condition is not matching, this condition is false, then this while loop will run q equal to q link. So in our list, as you can see, q equal to q link, we will come here, q equal to q link, we will come here, q equal to q link, we will come here, and now in the last q equal to q link, this is null, so it will not move forward. Okay, so in this case q will equal to null. Here as we will assign, this is the q link, we will come here, q link equal to q, q will come here. Now q will get the q link is null, so q link is null, this condition will be false. We will come out of this while loop and will return 0. Okay guys, so this is our check repeated data method. So in a create list, same way we will pass the data. We'll take the struct node pointer type of variable q and temp. We'll create the dynamic memory for the temp. So for this we will use the malloc. Struct node type of memory we want, we will call this a size of here. Okay, we'll pass struct node, this much memory we want. We'll do the typecasting of pointer type struct node pointer, and will assign the memory to this temp variable of type struct pointer. Okay, now node has been created. So this temp has two part, info and link. So in temp info we will store the data, and in the temp link we will pass the null. As you can see in the figure, this node temp info is blue part, here data will be stored, and temp link, this is green part, here address will be stored. So currently we are giving null. Okay guys, here we are giving null, means it is not denoting any next node currently. So here we will check if start equal to null, means linked list is empty, so temp address will be stored to the start, okay, start variable. So now temp will become the first node. And in the else condition, if start is equal to not null, means there is a other node also, means 2 3 4 maybe node maybe possible, okay. So in that case start address will assign to the q variable which we have taken here, q pointer type. So now we will check q link is not equal to null. If q link is not equal to null, then q will get the next node address. So as q will equal to null, means as we will get the last node as we saw in the figure, q link will get the address of the temp node which we created here. As we can see in the figure, after reaching here, q link will be null. So here as q link will be null, then we will come here, q link will denote the address of the temp here. So this 40 will denote next node. Suppose that we have entered 50 here, so here arrow will be, this cross will be removed and this arrow will be come here, and next it will denote to the next node, okay. And next node last address is null, as we already make null here, okay. So as I will run the program, then you will get the better idea. So just take some idea what is happening. After that we will clear the terminal and will print the linked list. In the add beginning, we'll pass the data, we'll take the struct node pointer type of variable temp, we'll create a node by this malloc method. Info part, we will store the data. Since we are calling this method at the beginning, so node will be add in the beginning of the list, okay. So now address of the start node will be stored in the temp link, in the link part, and temp address will be stored in the start pointer type of variable. So temp will be first, and here you can see temp link will point to whom start was pointing, okay. Or you can see like this, if you have some difficulty to understand what is happening. Start will print a address, so whenever we will print up this start, then it will print this address, this node address, okay. So this address will be contained by the temp node here, temp link. So if you see in the figure, suppose that this is our temp, so this green part will get the address of this first node, because this is going to become the first. So this is our start, so start has some address, so this address will be stored here. So this arrow will point to this node, okay. So this is the meaning of this statement. Start address will store here, start address will store here, so this arrow will point to this, okay. And temp address will store in the start, you can see temp up, now address of this node will become the first, so it will store in the first, means there is a pointer first, so in that address of this node will be stored. So now this node will become the starting node. Getting my point? So after this we will display the linked list, okay guys. Or you can see this statement like this also. Temp will print address of the node, start is also address of the node. So as already we have given this was the start node, this start node address is here, so this will point to this. Now this is not a start, we need to make this start node. So start was pointing to this, now start will point to this by giving the address of this node to the start pointer type of struct node pointer type of variable. Okay guys, so now let's move further. Add a node after a particular position. So we'll pass to data and position. We'll take a struct node pointer type of variable temp q, and q will get the address of the start node. Now so whatever position will be entered by the user will be passed by the user in this method. For loop will run accordingly, it will get the address of the node, and if q is equal to null, then a message will print there are no node at the position in linked list, and will return. Else will create the node will get the data and will assign the address. Okay, means q link will be assigned, means whatever address is denoted by the q link will be assigned to the temp link. Temp address will be assigned to q link. To understand these two lines, we can take the reference of this figure. Suppose that we want to insert a new data between 30 and 40. Suppose that we want to insert 50. Okay, so suppose that we want to insert this node, and we have entered the position. So here we are taking the we are counting the position from the 0. So this is the 0th position, 0, 1, 2 and 3. So suppose we want to insert the node after the third position, after second position, 0, 1, 2, after second position. Okay, so node will come here after second, so this node will insert here between 30 and 40. Okay. So now this is the q 30, this is the q, as you can see in the code q. So q link will be assigned to the temp link. Okay, this is the q 30, q link is this green part. So q link is 40, address of this node. So q link, this address will be stored here, temp link. This is the q link, this is the temp link. So as we will assign this address to here, now this arrow will denote this 40 like this. Okay, this is the meaning of this statement. Now address of temp will be stored in the q link. So as you can see in the figure, now this arrow is denoting to this 40. Now address of this temp node, this node will be stored here. So temp equal q link here. So as this address will store here, this arrow will move to this node. So this node will be successfully inserted between 30 and 40. This is the meaning of these two lines. Okay guys, after that we will display the linked list. Hope you got the idea. As we will run our program, then you will get the better understanding. Okay guys, so here now you can see delete method. Here we will pass the data which we want to delete. We'll take the flag, del flag 0. 0 means element not found, and if it is 1, then element is deleted. So we will set the flag further, as you will see in the code. So first we will check start info equal to data, means it is the first element. If it is true, then element will be deleted. means first element will be deleted. We will set the flag 1. Del flag will give the address of the start to the temp variable, and start link will store in the start because first node has been deleted. So now start will denote to the second node. We will free the memory of the first node and will print the linked list and will return. Okay, if this condition is false, means a node which we want to delete it is not the first node, then it will lie between first and last. So for between first and last, this while loop will work. We'll check this condition: q link not equal to null and q link not equal to null. In while loop we will check q link not equal to null and q link info equal to data. Means if it is true, then we will set the flag to 1, which will indicate data has been deleted. Q link will store in the temp link will store in the q link. Okay guys, memory will be free, which is stored in the temp, will print the linked list and will return. When this condition will be false, means a node is not between first and last, so surely it will be last node. Okay, so here we are assigning, we are going first to second, second to third, third to last node. So for the last node this condition will be false. So for last node we are checking another condition: q link not equal to null, q link info equal to data. This was the condition for the last node. Here we will set the flag del flag equal to 1 to indicate data is deleted. Now we will give the address of the q link to the temp, will free the memory, and now since it was the last node, so q link will be equal to null, because when last node will be deleted, then second last address will be null. Okay, to avoid the dangling pointer issue, you can understand it through a figure. When 40 will be deleted, okay, so now this pointer, since it is deleted, so it should not delete, it should not denote to nothing, so it will be null. This cross will come here, that will show the end of the linked list. Okay guys, so this is the meaning of this line. Now we'll print the linked list after deletion of the last node. We'll return from here. Okay, so here we will check node is deleted or not. So if del flag will be 1, then this condition will be false. If del flag will be 0, means node is not deleted, then negation will make it 1, and we will print this message: element is not found in linked list, and will print the linked list as it is without deletion. In the display we will take the struct node pointer type of variable q. We will check list is empty or not. If it is empty, then there is nothing will be display in the terminal. Okay, we will return from here. Otherwise we will give the address of the start node to the queue, print some message singly linked list, run the while loop, and till q is not equal to null, we will print some data. So data will be in this format. First we will print the address of the node, after that node will contain the data and next node address. Okay, so here we are printing the node address for our understanding, otherwise this much is only sufficient to print. Okay, so now q will get the address of the next node, and like this while loop will run and will print the one by one all the nodes. Okay, so this is some symbol. If q is not equal to null, means it is not the last node, then we will print some arrow to get the some visual appearance like this. Okay guys, so when while loop when this condition will be false, then we will come out of the while loop, will print the new line and some lines for some designing point of view. For the count we are taking, and in count method we will take some struct node pointer type of variable q, will assign the address of the starting node, integer type of variable cnt for counting, and we will run the while loop till q is not equal to null. We will get the another node by this line and will increment the count, and as q will be equal to null, we will come out of this while loop and will print number of node in linked list, value of the count which is increment here, which will be incremented here. Okay, and after printing this message, we will display the all the nodes of the linked list. In the reverse, we will take some variables of struct node pointer type of p1, p2, p3. We'll check linked list is empty or not. If it is empty, then there is no need to reverse. Otherwise, we'll check if there is a one element, then we can't reverse the one element. It is already one element. Getting my point, I hope. So we'll print the element as it is by calling this method display and return from this method. Otherwise, if there is a more than one element, then we will follow this logic. Give the address of star to p1, p1 link to p2, p2 link to p3, p1 link will be null, p1 address will be assigned to p2 link. Okay guys, if p3 is not equal to null, means this address is not equal to null, then again p2 will be assigned to p1, p3 will assign to p2, p3 link will assign to p3, and p1 will assign to p2 link. Okay guys, and after that we will assign the address of p2 to start and will print the linked list. So this is the logic to reverse the linked list. So as we will run our program, you will get the better understanding. So here for searching the element, we will pass the data which we want to search. Struct node pointer type of variable ptr will get the address of the starting node, position, here position is equal to 0. We'll run the while loop till ptr is not equal to null. We'll check ptr info is equal to data. If it is true, then we'll print element found at position. Okay, we'll print the data and position both, and we'll print the linked list and we'll return from here. Otherwise, we will get the next node, we will increment the position, and while loop will check the condition, and as this condition will false, we will come out of this while loop, and this condition will false when ptr will equal to null, means that node has not been found in the linked list. That will be the condition. In this case, ptr will be equal to null. Okay guys, so here we will print the message element %t not found in linked list, and will print the data which is not found entered by the user, and will print the linked list, singly linked list, by calling this method. And now it is our main body. So guys, I have explained all the methods and all the lines to you. So now need to compile and run our program and understand practically how we can create the linked list and what are the different operations which we can perform. So let's move. So we'll write wq, will come out of the program. Okay. So here first we will compile our program. GCC linked list -1 .c -o linked list, press enter. So our program is compiled successfully. Now we'll run our program. So we'll write dot / linked list, we'll print enter. So we'll get the menu like this, singly linked list menu. So we have 9 options: create linked list, add at beginning, add after, delete, display, count, reverse, search and quit. So first we will try from this option 3 4 5 6 7 8 9, because there is no element this time, linked list is empty. So first I will enter 3 and we'll check what output will come. Linked list is empty for the 3 because there is no element, so after which we will enter the data. Okay, so now I will enter 4 for delete an element. Linked list is empty, same message. For 5 for display, linked list is empty. For 6 for counting, linked list is empty. 7 reverse, linked list is empty. 8 linked list is empty. Okay, so for option 3 to 8 we are getting the same message, linked list is empty here. So means first we need to make a linked list. So I will enter 1 to create a linked list. I will enter. So it is asking a message, it is showing a message how many nodes you want. Okay, so suppose that in starting I want to enter 3 node. So I will write 3, press enter. It is saying are you sure? If I am entering n, press enter. I am not sure, so it will again enter your choice. So I will write 1, enter. How many node? 3. Are you sure? Why? Now enter the element. So first I want to enter 10, press. So we are getting singly linked list, we are getting our node 10 and next node address is nil. Okay, as you can see in the figure 10, since this is the first node, so it is not having any other node this time currently. So this is the null, this cross is here, and this is the address of this node. Okay, now if I will enter same value again 10 for the next node, because 10 is already available in our list, here you can see. So I will press enter. So it is showing message 10 already available in linked list at position 0, which is true. Now it is asking again enter the element. So I will enter 20. So here you can see now 20 has come. Okay, this is the address of the node. This node has the data 20 and next node address is nil. So this address is here in the next part. This is the queue node, this is the queue info, queue data, and this is the queue link. Queue link is this address and this address is same. Getting my point? And this address is this node, means second node. So like this I am entering another node 30. So like this you will get. So now this is our second node, and this has the queue link. Queue link has the address this node. This node address is this address, and this address is same, you can check. So we have 3 nodes currently. Okay, so now I will enter another. Suppose that I want to enter another node after this 30. So I will use this option 3. So as counting will start from the 0. This is the position of first node, 0 1 and 2. After 2 we want to insert another node. So I will enter 3. So enter the element. I want to enter 40, press enter. After position, so after 2 I want to enter. So after 30, this node 40 has been inserted. So we are getting here list 10, 20, 30 and 40, as in figure you can see 10, 20, 30 and 40, and last node link is null. You can see in our program also it is nil. Okay guys, so here as I already told you, don't be confused. Here this is the address of the node, this node, for your understanding. Okay, so here 30 next node address is this. You can see this address and this address is same. You can check. So like this our singly linked list is created. So now we have some other options also. Suppose I want to add an element in the beginning. Before 10 I want to add another element. Okay, so I will enter 2. So I want to enter 50. So 50 has been inserted before 10. This is the node, this is the node address, and this address will be next address of the first node. Now first node is 50. Okay guys, so this arrow is denoting to this node because this node has the address is this, and this address is in the link part of the first node. You can check, that's why this arrow is here. So now our first element is 50. So our list is 50, 10, 20, 30 and 40. Okay, so we have checked 3 options here. So we will come to delete later. First I will enter 5 to display the list. So this is our list which is created. Okay, so now I want to count how many number of nodes are there in the list. So I will enter 6. So number of nodes in linked list are 5, which is true. 1, 2, 3, 4, 5. Now reverse. Currently order of the linked list to print the data is 50, 10, 20, 30 and 40. I want to first print 40, then 30, 20, 10 and 50. So what I will do, so I will enter 7. It will reverse the linked list. You can see 40, 30, 20, 10 and 50, and accordingly and node next address will be changed. Okay, earlier it was the null, now it is denoting the address of the this node which contain the data 30. This address and this address is same, that's why this arrow is pointing to this node. Okay guys, same for the other nodes, you can check out. For search I will enter 8. Okay guys, so I want to search a element 70 in the linked list which is not available. So what message I will get? Element 70 is not found in linked list, which is true. 70 is not in our linked list. So I will do again 8. I want to search 30. Element 30 found at position 1. So as I told you, position index will start from the 0. So this is the 0th position and this is the first position, so which is true. 30 found at position 1. Suppose that I want to search 10. So element 10 found at position 3. So 0, 1, 2, 3, which is true. Okay guys, so we have tested these options. Now last is delete. So we will check this option also. Suppose that I want to delete 10. So as I will delete this node, then currently 20 next address is this node address. This node address is this. You can check A80 A80. So after deleting of this node, this node which contain the data 20 will contain this address. A node which contain the data 50, so this address will be stored here. A node which contain the data 20, and this node will be deleted. So let's check. Delete. So I am entering my choice 4 and I want to delete 10. So you can check, 10 has gone, now 20 and we have 50. These two nodes we have, and 20 next address is this B00 B00. Okay guys, so hope you got the idea. So like this, if I want to delete this node 50, then 20 next address will be nil. Currently this node has the address nil. So let's delete 4. So I will enter, I want to delete 50. So 50 gone, you can check, this node has the address nil. Okay guys, so hope you got the idea. So one by one I can delete all the elements. Suppose I will delete this node which contained the data 30, then this 40 and 20 will be connected with this address. Okay, let's delete 30. You can check, now 40 next address is this, which is the address of this node containing the data 20. Okay, now let's delete 20. Now this node contain the next address nil because this is the only node. Okay guys, so now I want to delete 40 also. So I will enter my choice 4. Suppose that I'm entering another node which is not exist in the linked list. I want to delete 60, or I want to delete 20 which is already deleted. I will enter, so it will show the message element 20 is not found in the linked list because it is already deleted. So I will enter 40, okay, for the deletion. So I will enter 40. Now we'll get linked list is empty because 40 was our last node. So guys, we have tested all the options. We have created the linked list. We have added the node at the beginning. We have added the node after a particular position. We have deleted the node one by one. We have displayed the linked list. We have count the number of nodes. We have reversed the linked list. We have searched the data in the linked list. Okay guys, so all the operation we have tested. So if, now I will enter the 9, then I will suppose I am entering another value, then what message will come? Wrong choice. And if I will enter the 9, then I will come out of the program. Okay guys, so guys, hope you got the idea what is a singly linked list and what are the different operations which we can perform. So do practice. Thank you so much. Bye bye.